Hi everyone, this is Jay, your instructor for Computer Networks. If you want to connect your device to the internet, the primary requirement is that that device should have a unique IP address. There are two types of IP addresses, the IPv4 and IPv6. The number of IPv4 are 4 billion, and because of so many devices are connecting to internet due to the internet of things, there are nearly 20 billion devices right now are connected to the internet. So if we are still using the IPv4, that is not possible. So that is why they have developed the IPv6. But let me tell you one thing, that still we are able to use the IPv4. We are not ran out of the IPv4 addresses. So even if there is IPv6 available, we are still able to use the IPv4 to connect the device to the internet. And what is the reason behind that? The reason behind that is called NAT, which is Network Address Translation. So the IPv4 addresses are divided into 5 classes, which are class A, B, C, D, and E. Class A, Class B, and Class C are known as unicast IP address. Class B is for multicast and Class E is reserved for development purpose. So in each class, IP addresses are further divided into two categories, which are public and private IP addresses. Now, what is the meaning of the public and the private IP address? Public IP addresses are those using which you can access the internet. You can communicate over the internet. So when you are purchasing plan from your internet service provider, they are assigning you one public IP address to your device so that you can connect over the internet, you can communicate over the internet. If you have private IP address, your device cannot communicate over the internet, but your device can communicate over the local area network. And to use the private IP, you don't have to pay anything. So that is why if you want to create a local area network which is very large, you can still create it, you can still communicate those devices within that network using the private IP address. But if you want to connect the devices in your local area network to the internet, in that case you have to provide each and every device unique public IP address. So this is a range of the private IP address in each class. In class A, 10.0.0.0 to 10.255.255.255, it is a range of private IP. In class B, it is 172.16.0.0 to 172.31.255.255. In class C, it is 192.168.0.0 to 192.168.255.25. This is the range of public IP address and this is the private IP address. Now let's try to understand with the example. You can see on the screen, 3 devices are connected in the local area network, and let's assign the IP addresses to them. So the first device is having IP address 192.168.10.3, then after 192.168.10.4, then 10.5. The routers may have more than 2 interfaces, and in each interface it will have unique IP address. So the interface at the local area network side, it is having the IP address 192.168.10.1, and the interface at the wide area network side, it is having the public IP address which is 138.76.29.7. So let's assume that we have purchased plan from the internet service provider and we have purchased one unique public IP address and we have assigned that IP address at that particular port. Suppose the device 192.168.10.3 wants to send message over the internet. So it will create the message. Now in the message you can see that the source IP is 192.168.10.3 and the port address is 22. What is port address? The port address are assigned at the transport layer and they are assigned by operating system. The destination IP is 32.103.10.1 and destination port address is 80. So this message will be sent to the router. In the initial stage, the router's table, the network address translation table, is empty. You can see that there are two fields, which is LAN side and the WAN side, and both fields are empty. So this device will send message to the router. When the router receives this message, it will analyze this message and it will make change in this message. Now, why the router cannot forward this message? Router cannot forward this message because this message contains private IP address. If this router forwards the message to the internet, no other routers will forward the message to the further device. Because when router encounters any message that has a private IP, they will just discard that message. So in this case, this router will make change in the message and it will make entry in the network address translation table. So you can see that the source IP is changed from 192.168.10.3.22 to 138.76.29.7 300, and this message will be sent to the destination. Now destination will reply with the message. You can see that the message which is received from the destination is having source IP 32.103.10.1 and port address 80, and the destination IP is 138.76.29.7 300. So this is the IP of the router. Now router knows that it has converted the IP address from 192.168.10.3 to 138.76.29.7. So it will make change to the message and the message will be delivered to the device. So what we just did is that we have mapped one private IP with the public IP address. Because to communicate over the internet, we require the public IP, right? So using the private IP, we can still access the internet. Suppose the another device 192.168.10.4 wants to send message, so same procedure will be followed. When in the initial stage the table is empty, the LAN side and the WAN side is not having any entries. When the router receives the message, it will analyze the message and it will make change. So it will change the source IP from 192.168.10.496 to its own IP and its own port address. So you can see that in the net table the entries are being made, and then after you can see that in the message the IP address is changed from 192.168.10.496 to 138.76.29.722, and this message will be sent to the destination. The destination will reply with the message, and when router receives the message from the destination, so from the net table, it knows that this message should be forwarded to device 192.168.10.4. So the message will be forwarded to the destination. So if we have created local area network, and in that network, if each and every device is having private IP address, still we can connect over the internet using only one public IP address. So that is the most advantage of using the network address translation. So this is how the network address translation works. This is it for today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.